Thank you. Got it. Sorry, my videos should be on, but I can't see myself, so just bear with me anyway. So when the Crowchild Trail first started out, we were really worried about that. The traffic was bad enough anyway, but what would happen if, when they were trying to do the work? The actual bridge we now see has had extra lanes added. The traffic flows a lot easier, and equally, well, surprisingly enough, during the construction, the traffic flow was actually, some people thought it was better than it was before the construction. So it's one of these jobs where we're all thinking, how the heck did you do it? So we'd love to hear from David tonight to tell us how he did do it. We're really looking forward to his talk. And thank you very much for that.
So I guess it's over to me.
Yeah, all yours.
Everybody can hear me well and see me. So I'm Dave Nagy, and I'm with Associate Engineering. I guess the first thing that needs to be said about the presentation or even the project is that this is multiple people, multiple entities, Graham, WSP, ISL, Cowie, ourselves, the City of Calgary, multiple divisions within the City of Calgary. We've got the roads department, parks played a role, pathways, the transportation infrastructure group. So I guess what I'm trying to say is, like all good things, I will take all the credit for it today. So today we've got a couple of things that we're going to probably hit on, but I'm sure all of you have read that, and I hope we hit them all. But if not, please ask questions after. So the original structure, and what we're going to talk mostly about, are the scope that AE was responsible for, and I'll delineate that in a couple of slides. But so for some context, the bridge over the Bow River, which is the actual linchpin to all of this story, was constructed in 1968. On an average day, it sees about 100,000 cars. And the problem, and the reason why the city, commuters, people, public, everybody was concerned with this project is the amount of gridlock and how bad traffic would get. And one of the key establishing points that needs to be considered is, in the 1970s, Calgary was, somewhere between, at the beginning of the 70s through the end of the 70s, it was a 300 to a 600,000 person city. And the way we see it and know it today, it's 1.4, almost 1.5 million. It's the fastest growing city Canada has ever seen. I heard that on a radio, so don't go looking whether those stats are real or not. But for those that have been here for a long time, truly understand what I'm saying. So the original bridge and this corridor definitely was in a state of repair. It needed some attention. This is some substructure that has deteriorated, I guess you could say, a little bit quicker than others because of a leaky expansion joint. But it is pretty indicative of most of the substructure. The superstructure, though, we found was in remarkably decent shape. Obviously, for those that aren't bridge engineers, the substructure is everything below the deck. So all this stuff right here is substructure. I hope you guys can see my pointer. And then the girders are the beams going across. That would be superstructure. So it's kind of this dividing point. So when we got together with the City of Calgary, originally our scope was a rehabilitation, just to fix some of this stuff. But within our proposal, we had identified, just because of the uniqueness of the structure and the robust nature of its design and the way the system was working, identified the ability to add an extra lane on, which would relieve traffic, we felt at the time, substantially. But moreover, we also noticed that the ramps, and we can talk about this again later in the presentation, the ramps that were introduced later in the structure as the city grew, so to create some connectivity within the city's network, weren't helping. They were coming in non-intuitive ways, and it would just the driving through this portion of the corridor really elevated the driver's demand. So you really had to think about what lane you were in. There was some lane drops. There were all sorts of things happening as a driver that needed to be considered. So when we took this on and then it grew into what's called the Crowchild Short-Term Improvement Project, main focus of the expanded scope was to improve functionality and improve the safety, get some more life out of this corridor, but also relieve a lot of the pressure of traffic. So within that bigger context, there was 6 bridges, and I'll go through and just let you guys know which ones we did, which ones our partners did. But one of the things we came together with the City of Calgary was, despite having multiple consultants on different aspects of the project, there would and should be one contract. Just make it easier so that you don't have interfaces where one GC, and GC I mean a general contractor, where one GC is arguing with another who's responsible for that work, who was supposed to price it. Among all of the traffic that Richard mentioned at the beginning, all of the traffic accommodation, there would have to be all this extra coordination between contractors for the implementation of it. Now, for major detours, the City of Calgary took care of those. But for just the general day-to-day, got to get some workers, got to get a thing done, that was done by the contractors. So we saw a lot of efficiency by having a one contract. So we've got multiple bridges in this corridor that were all repaired, that all of you as Calgarians that drove through here would have witnessed construction. This one at the very top, this one at the top of the screen that you guys are looking at, this one was done by WSP. I think I just saw Jai pop on the call. So he was actually responsible for this bridge. So another chartered engineer. So I wouldn't drive over this bridge if I were you guys. It's tough to have a joke in a virtual forum. And this is this is bridge 3. This was done by us, AE.
He's a funny
bridge
guy.
2, bridge 1, and then there was we were able to fit in a couple of expansion joint and surface repairs, I guess, to bridge 5 and 6 over here. So this was, and you can see it's so nicely delineated by this air photo, all of the nice new dark asphalt that was put in. So then the next photo really speaks to a lot of those traffic detours that we were talking about. So when we're coming down from the south, this was one of the things that was mentioned in our proposal. I guess it's being translated. So this detour was a suggestion brought in our original proposal concept, and this was one of the staging photos that was brought in. We very much like it because it shows not only how the traffic kept going, all lanes of traffic were maintained, so there was no loss of capacity in terms of functionality during the construction. And you can see pretty much all of the activities going on. You've got retaining walls being built on the south approach. There's CP tracks over here. We've got the Bow River, and then this is all brand new widened deck. And then it carries on through and then up to the north. So there was one of the key things, I guess, would be the detailed and thoughtful design of construction sequencing and traffic staging that really helped create the vision of the project. Sometimes we have great ideas as engineers, but they don't always work out in constructability or in practice, and so we have to get back to the drawing board. This one really ended up working out well for us because we brought what I think was a vested and vetted, thoughtful design that included constructability. So when we're talking about the corridor and where it was and why it didn't work, this is our favorite slide. So coming in from 10th Ave or Bow Trail, which were predominant flows in PM peaks. So these are all the folks leaving the downtown core and trying to either access Crowchild to the north, where there's a substantial amount of population and travel trip, or they're going to take Memorial to get westbound. So originally, if you all remember, as you all remember, you would come in and you would enter into the corridor from the left-hand side, which is definitely not the standard. Sorry about that feedback. I think, so that's not the standard practice, and certainly not the best way of doing it, especially when you got to consider other people that are trying to do the movement going from either Bow Trail or 10th and then want to go east to hit the center of the city. They've got to weave through 2 lanes of traffic at the same time as the mainline Crowchild traffic is proceeding down the corridor, but this outside lane, the 2 lanes that were currently there, drop. Because if you don't get out of that lane, now you're going eastbound on Memorial Drive. That created a lot of confusion, and for anyone that wasn't a regular traveler, would get caught in that lane and cause a lot of the gridlock, or the game that a lot of us would have experienced, that driver that was just pushing the very end of the line and cut you off to get back and skip a couple of cars. So with our project, what we looked at was definitely relieving that. And in order to do that, we needed to create a proper entrance for these two movements. So we've moved those ramps, the 10th and Bow, onto the left-hand side, or to the right-hand side, excuse me, of Crowchild, and they would enter. And then we actually were able to, with the widening of the bridge, carry 3 full lanes of Crowchild all the way through this. So as you're driving down Crowchild from the south going north, there's no more confusion of, oh no, I got to get out of this lane. You just carry on, and those that are entering Crowchild, now they're the only ones responsible for making effort and extra movement. So it, in a sense, it definitely relieves a lot of the driver's workload. So to get into a little bit of the nitty gritty, this is what the bridge looked like before, pre-construction. And then this is our strategy and how we were able to implement a widening. So this is the south approach over here. These are the only 2 land-based piers that were founded on piles. All of the rest were on spread footings. And I wish I could tell you that they were all on bedrock, but unfortunately that wasn't the case. So we had to do a lot of geotech investigation just to understand how well our load transfer would go. And looking at how the bridge was built in stages, and a lot of the fills were uncertain, and we couldn't get the geotechnical kind of responses or appreciation or understanding of what we were dealing with. we then had to come up with a structural fix that would divert load off of these spans and onto the founded spans. So we created a link slab across girder, across Pier 9, which then made it a fixed point and allowed a lot of the movement and vertical load, live load distribution onto these two piers. So this pier is really responsible for a lot of the load on the south, and this pier is responsible for a lot of the load coming from the north. And here is what it looked like in construction. So going in clock, I guess this would be clockwise. Let's start at 1 o'clock. This shows a pier where we've added dowels. If you remember or saw on that previous slide, we created shells around all of the piers and the spread footing. So this is the original existing size of the pier with its pier cap, or rather pile cap. And then what we did was we added, well, in total, 40,000 dowels to all of the piers to create a shell around it, which you can see here. It's a full shell of half a pier. Here's the bottom half of a pier column with a bunch of dowels that will go up, that will link into the future expansion of this, what we call the hammerhead, or the pier cap. And this picture just shows that the state of repair of the concrete was so poor that when we started chipping, and the original strategy by the contractor was to just do all the chipping first, and then whilst pouring the concrete for the shell, it would then fill in the areas that were chipped out. The only problem was the chipping resulted in more cross-section loss, which meant capacity went down substantially. And because of other works and loads that were going on, it became a concern that the integrity of the system was being compromised. So we needed them to rethink their strategy and start pouring sections of the column to re-establish the integrity that was already there. So some other highlights as I was, so we're still on the south approach. Because of this new ramp coming in and the old ramp being demolished, this whole section of the bridge was no longer required. So we took advantage of that, and instead of just leaving it in place and having the city have to manage another liability over the next 30 years that was doing nothing and function and not providing any function, we rearranged these girders on the span 10. And it was actually quite a complex construction process because we had to demolish one of the piers, and I'll show you a picture of that in the next photo. But this was a very complex operation that all happened while people kept driving and didn't realize that they were sitting, or driving rather, across across this temporary framework that's holding up these girders. And then this pier actually eventually, this pier, so this is all temporary false work holding up these girders, and this pier eventually gets removed, and another big frame comes in, supports these, and then these girders are removed, and then we create this beautiful gap. So that's the south approach. On the north approach, which was over top of the river, another constraint that we had to consider was interesting because this span was fixed in its original formation, but we had concerns because we had floods in 2013. Were there any scour concerns underneath all of these spread footings? And secondly, due to the time that we wanted to We wanted to get this project executed and implemented.
你车怎么还开着？啊
That's a translation again.
Oh.
So we didn't want to go into the river because anything to do with a major waterway like the Bow River requires a lot of regulatory permitting, and it just takes time. It's not that it's overly difficult as long as you follow their rules, but it just needs to be approved and accepted by the regulatory bodies. And we didn't have that luxury. So we again derived a system that kept us out of the water. And if you guys remember that, where I showed you those two piers with all of the foundations, the pile foundations, the one pier that was on the north end, it is now taking the majority of the new load distribution from adding the lane, whilst these piers, as they stand, continue to accept the original load. And so the way we were able to distribute it is the fixation of this system, but moreover, we created a higher stiffness on that one pier so that the load would get attracted to it. I'm led to understand not everybody's a bridge engineer on this, so basically the way this bridge was built originally allowed us to consider that as a concept that would be feasible. Sometimes with other superstructures, if it's steel, older steel, it's just not the same quality it is today, or a multitude of factors wouldn't allow us to do that. But this bridge was totally open to this concept. So our biggest challenge on the river piers, these 4 piers, was the fact that we now were extending the pier cap and it's become a cantilever. So from this point all the way to that point, it's just hanging, which creates a massive tension face at the top. So we were struggling to get enough rebar, or the right size rebar, under a certain size of concrete dimension. And we were able to achieve it without any post tensioning by increasing the width of that cantilever to a 400 mil shell versus what we were trying to do with a 300. And then it also gave us the room to put in our new girders for the whole new lane. And again, all of traffic was still carrying on up top on this deck. We removed this median and barrier to allow the different shifts in the detouring. For this just shows the intermediate diaphragms, which were pretty important. And it also shows that the original ash toe girders that were here were not the same depth as what currently is available in the market, which is a 1600 NU girder. NU is Nebraska University. So we had a shallower or a less deep girder, which was helpful because there was a crossfall in the bridge that needed to be considered. And so that little extra bit of space, we kept the soffit and the soffit line, which is this underside of the girder, which essentially reflects the way the deck is falling from the crossfall from the high point. And we were also able to carry the diaphragms to the outside of the girder to give it this aesthetic look. And we felt that sometimes it's the small little details that get missed, but they add a little bit. So then the next, and this slide right now, the only real, it's showing everything. It's showing these big, massive new piers that have been constructed and tied together. And it shows the new girder line with the deck and the new barrier on top. But more importantly, and this is one of the last constraints that this project had to deal with, and because there's some electrical folks, NMAX had 6 transmission ducts, so 25 kV plus power going across this bridge. and it was extremely important to the network, to their network. All of these were leaving the substation and making their way to a distribution to the south. And so we had to first of all, when we did all of the bearings, we had to jack the bridge and make sure all of the loads of lifting a bridge line, a girder line at a time, didn't impose any extra stresses on the bolts, on the ducts within the metal ducts within the bridge deck. But moreover, we severed all of the ducts in that, where I showed you where those girders were removed, the 7 girders on the south end. So we reinstated all new duct banks, and you can kind of see the concrete bump out right here. You can really see it in this diaphragm. So we reinstated 6 ducts for NMAX to carry their new lines across. And this is one of what they call a bird cage. This is where they get access and they can stand and look at how the splices and how they've pulled it through. Whatever electrical guys like to do with their wires, that's where they go and do it. And this is how they get to it. So this is the new widened lane that we added to the bridge with the new barrier. And that's NMAX's new access to that bird cage. So that just sort of completes the story. So the other part is a 200-meter long retaining wall, 12 meters high on the northbound ramp. And I showed you this is basically how we realigned 10th Avenue and Bow Trail onto the Crowchild corridor. It was, all the fills here are not good. There was lots of challenges, but while the regular individual was driving on top. So this would be a picture of the traffic and all of our activities. This is what was going on underneath. So we're building these retaining walls, 3 tiers. Most of the load is founded onto these piles that were driven in the first tier of the wall. And then the rest, and so that's what's actually coming through the slip plane as well, these piles. So it's adding some global stability to the whole wall system. And then we have a hybrid function where you've got piled soil anchors, and then the next tier is an MSC wall, and then the final tier is another MSC wall. There was lots of challenges with the straps of the MSC walls, but one of the big cost savings was finding this hybrid system, because going straight up with a full cantilever retaining wall, cast in place concrete, was very, very expensive. And this actually brought the costs down by quite a bit. This is just construction, very narrow site. 10th Ave continued to allow traffic movements and access to all the businesses. Then the next bridge is Bridge 2, is the way the project called it, but it is the Crowchild Bridge over top of eastbound Memorial. So this is what it looked like in its original state. And then we basically just widened it. Really, this plan shows the deck widening in green. The piers were widened by extending the pile caps to support the new columns to replicate the originals. The span above the traffic is precast rectangular beams instead of cast in place T-beams, because they don't exist anymore. So this system doesn't exist. And so a shallower depth fascia on the girders was used to maintain the same clearance or headroom for traffic going underneath. Less complex, but again, still very important to achieving all of the functionality we were looking for within the corridor. And then this last one, so to add a third lane, we've got 2 lanes is the original picture. To add a third lane, we had to scoot it right in and go underneath this pier. The pier caps originally had capitals that came down, and the rebar actually ran from the capital all the way into the deck. So we had to come up with a new system to reduce or to increase the clearance underneath the bridge and maintain the integrity. So the system we used was basically over the piers. We put it up essentially a pier cap and we post-tensioned it. So we were able to remove these capitals that were reinforced and then add in the new green stuff with a bunch of reinforced concrete that's shown below and increase our clearance. It ended up looking like this, 3 lanes. And to be honest, as a driver, I don't think anyone even notices how close they get to these piers, but worked out very well. So the final results, cost savings. So where does that come from? There were several iterations of a corridor study to try and bring capacity into here. The city engaged Stantec at first, ISL next, and in a functional plan, they're looking for the best way to fix it. So often the results were an offsetting parallel crossing across the river, and that would be expensive, especially when you started considering land acquisitions. So there was this project in the short term certainly brought in a lot of relief, and the $87.5 million price tag was substantially lower than the close to $1 billion first one that was rejected by council. I guess the only other thing that I was going to say is the Crowchild Bridge project was really a collaboration, like I said at the beginning. There was multiple partners, efforts with the City of Calgary, many engineering firms, and construction, many partners within the consulting group. And one of the successes was how well all of the partners, the consultants, all worked together. While the presentation did focus on a lot of the technical elements that AEs contributed to, a large portion of it was in terms of public management and communications was covered by some of those partners like ISL. And I would say that the City of Calgary, prior to construction, conducted an extensive public engagement, and they invited thousands of Calgarians to submit feedback, which helped the collaboration, and at least it helped solidify the feasibility of this. So Associated is very proud of our contribution to the Crowchild Trail. And now questions, if there are any.
Okay, so does anybody have any questions? Maybe ask or stick your hand up.
Richard here. Just one question really. You said that originally the intent to have an extra lane was not really was just down as an option on a proposal. Was there sort of a eureka moment at one stage when it was decided to add the extra lane? And presumably people were starting to talk about costs as well. So what you're saying is you've saved a lot of money doing that as well.
Yeah, that's a good question, but that's a different presentation. It's a long story. I think Dawn Gow is on this call. Maybe she can talk about some of the collaboration. But it did start out with one of the city employees. He was the roads senior PM at the time, Craig McFarlane, and he helped spearhead and bring in a lot of the other individuals within the city and really, asked us to investigate the true feasibility of this solution. And then we started to collaborate with ISL, who was doing the functional and the public engagement at the time. And then it started getting introduced into some of that public engagement. What about the idea of this? Which then we got some political winds started blowing in our sails. And then the story carries on. It was right around election time. So, things had to be put on hold. We didn't want to advance things too far. We would like to try and take advantage of some early advanced contractor engagement. So that, like there's a lot of things that happened really quick. But the idea was born in a proposal, mainly because our folks out in BC have just finished doing this to 2 other bridges that had very similar characteristics. And as I was saying earlier, that was an important part to the feasibility. Not every superstructure or not every bridge system can actually benefit from this kind of a rehabilitation and widening and improvement. So.
I have one question in chat and then we'll go to Max because he's got a hand up. So Dave, in the chat it says, for pier repairs, to what extent did you end up facing bad concrete?
A lot, but we still told that this was a very green project because we used a lot of existing concrete. So I don't know the actual volumes, but at certain stages, I would say we got very close to, maybe 30% removal, maybe less, 25%.
Wow.
But like I said, it was done in a staged process. So.
Yeah, thanks, Dave. So that's why you had to rebuild some of those piers along the way. Max, you had a question there?
Oh, thanks. That must be Nigel.
Yep.
Yeah, it's the same, Max. And good presentation. I think the project did really well for the cost of $87 million for the scope. However, the schedule of construction was annoying, at least to me. I drove over the bridge many times. It took 3 years. I just wanted to, can you shed any light? What had caused such a lengthy construction schedule? Could have been done differently?
Well, there was, it's an interesting question, Max, because there was some original ideas of what schedule should be. And just because of some advantageous pricing we got, scope was able to grow. So we never really kept, or, the project had target dates that it definitely wanted to get things done. But I think the whole project, the whole city, everybody realized it would be more of a miss if we didn't go and fix a couple of those other bridges. I don't know if you caught the beginning of the project or of the presentation, but bridges 5 and 6, those were add-ons, and some extra work on bridge 1 was required. And instead of closing up the original scope, the city took advantage of the ability and the forces that were there. And, they went through the proper procurements and were able to increase the scope so that everyone during COVID could enjoy construction-free Crowchild. So to answer your question, maybe a little bit annoying, but I think, you're going to forget about it all. And there's going to be a lot worse traffic jams that you're going to be in.
Yeah. Any other questions?
I'm just curious about the increase in the capacity. It's an interesting bonus that you've got the realignment, and that's a plus for sure. But I wonder how many, you had 100,000 cars per day using the bridge. Do you know what the estimate would be for its capacity now?
So are we talking about the functional capacity? How many cars it would take?
Yeah, yes.
So from the modeling, and that's the best we can give you, it was obviously at an F before, and I believe we've brought it to a C. And Crowchild, Deerfoot, these kind of corridors will induce demand. So the more capacity you add to them, the more people will start taking it, because they'll see it as a free flow movement until such time as it jams up. So capacity, how much more could it take before it hits an F? It's a good question. the answer really is still at the
Well,
bottom.
it's an $87 million question, actually. This is the thing which dogs all planners. If you increased the width and you didn't get any real benefit other than the realignment, people would be as mad as hell. I think as happened, you will see big benefit, and that's an interesting point you make about once you've got it built, people will come.
Yeah. Well, the improvements were much beyond just capacity, right?
Mm-hmm.
We say like the safety aspect is substantial. Yeah. And the cost of 87 million is a drop in the bucket. It's not even the rounding of a parallel new structure. So, you're looking at a couple $100 million to get a parallel structure beside it.
I suppose what may be permitted another question, and that would be, given your experience with the piers on that bridge, could that knowledge be transferred to the infrastructure in other parts of the city in terms of estimating how much we really need for a rehab of the whole infrastructure?
Absolutely. I think it's definitely going to open up some consideration. We're going to take different, I believe the city and most municipalities are going to look at the assets they have, and that's exactly kind of the new way of looking at it. What revitalization would be required to get an extended period rather than blow it up and bring in a new one. Certainly across, sometimes it's certain constraints make it more obvious, right? Like big water bodies like the Bow River to Calgarians. We don't have a lot of river crossings, but they're more critical versus, just some overpass over Stony Trail somewhere. I don't know, in 70 years, maybe the Northeast will just, I don't know. Some of those substructures were also, in the P3 context, they're not as robust. They were done on a competitive open bid where dollar wins. And so get the lowest, the cheapest, the most economical substructure you can find.
Yeah. Are you done, Alan? Are you done, Alan?
Oh, yes. Yeah. Well, just on that point, that this whole business by taking the lowest bid, I often wondered when Neil Armstrong was on his way to the moon, did it cross his mind that NASA took the 3 bids and the lowest award?
Good question. I think Dave will answer that one. But Dave, there's another question in chat here, was how much was engineering modified during construction as a rough percentage?
Not too much. Not too much. More on sequencing how pours could happen, but there was the deck rebar is a big one. It was oriented not the way we expected, not the way it should have been. So during the original construction, the builders, constructors took some liberties to make it a little bit easier for themselves, but we were able to come around some of that stuff. But no, nothing big at all.
Nothing big at all. Okay. Any other questions? Anybody got any other questions? Well, okay. In that case, I'd like to thank Dave on everybody's behalf for a fascinating talk on something very innovative and very inventive. Some really smart engineering in there, Dave. Really appreciate you telling everybody about it. Great presentation, much appreciated. And so at some point, we'll manage to get to you, CPGC will get to you a certificate from Operation Eyesight showing that somebody in another country has now received eyesight because of your talk tonight. And we really appreciate you giving us your time and giving us such a really informative talk. Thank you very much.
Thank you. Thank you, everyone, for allowing me to talk.
Thanks, Dave.